Our first speaker is Steeley Ellis. And Steeley is a master's student in Tina Wadowski's lab right here at the University of Guelph. And we're going to learn from Steeley about how painful conditions in older laying hens may affect their mobility and their choices and the choices they make to reach nighttime roosting perches. Here's Steeley.
Thank you, Carol. I hope none of you are sick of hearing about chickens yet. Great. So for a little bit of background, this is the red jungle fowl. It's a wild bird that we started keeping thousands of years ago for their meat, eggs, and their beautiful feathers. Over time, we've genetically selected these birds for higher egg yields, resulting in two main phenotypes of commercial hybrids: the white feathered hen and the brown feathered hen. White feathered hens derived from white leghorns and the brown from Rhode Island Reds. If you ask the average person what the differences are between these laying hens, they'll probably tell you that brown eggs come from brown birds and white eggs come from white birds. But what if I told you there were more differences than that? For example, when compared to white birds, brown birds tend to roost in lower locations and perform fewer aerial transitions, which is when the bird will jump and use their wings to move between levels in an aviary. Without taking their differences into consideration, we could be putting birds in housing systems that may not meet their individual needs. So daytime perching and nighttime roosting are highly motivated behaviors in modern day laying hens. To understand why, we can look at those jungle fowl. These birds would roost in trees at night, which helped them survey their environment and keep out of reach of ground-dwelling predators. In our modern commercial facilities, we've eliminated those threats, but the motivation to use perches hasn't gone away. A study by Olson and Keeling found that when birds were able to see a perch, but it was covered by plexiglass, which stopped them from actually sitting on it, or the perch was removed altogether, the birds made more attempts to take off and walk around. So they interpreted these findings as signs of increased frustration and exploration for the birds trying to find a safe place to roost for the night. So now that we know that they want to get up to somewhere to sleep for the night, how exactly are they getting there? Well, in natural habitats, feral domestic fowl would fly up to the lowest branch in a tree, then move branch by branch. In commercial aviaries, birds might use perches or platforms to do this. However, unlike tree branches, these are typically spaced further apart. Longer distances and steeper angles between the perches have been shown to cause higher forces on the keel, which is like their sternum, and are more difficult to navigate, especially during downward transitions. Failed landings were also seen more often when birds were landing on perches when compared to landing on the litter. A study by Wrench and colleagues found that when ascending, most laying hen pullets, which are young birds that Anna presented, chose to use aerial locomotion no matter what kind of housing system they were raised in. And when descending, the pullets that were raised in an environment with ramps chose to use the ramp as long as the angle wasn't too steep. So if a laying hen can just use perches to move throughout the aviary, why do we care about ramps? Well, ramps can reduce collisions, falls, and keelbone fractures. And not only that, but when ramps are available, the birds want to use them. A study by Peterson and colleagues found that birds trying to move between levels in an area of an aviary with no ramps showed more behaviors like crouching, pacing, and stepping on the spot, which all indicate hesitancy. Other research has also shown that when birds are raised in environments with ramps, they'll use elevated structures more in both their rearing environment and their laying environment. So despite the facts that ramps have shown benefits, the Canadian Code of Practice for laying hens and pullets still only recommends the use of ramps in multi-tier systems. And since laying hens are a ground-dwelling species, they're very reliant on their feet. They use them not just to move, but also to forage in their environment and defend themselves. With no shoes to protect their feet, they can develop excessive skin growths, swelling, lesions, inflammation, and necrosis, which can be caused by things like a wet environment, mites, and infection, and it's thought to be pretty painful for them. A study by LeBlanc and colleagues found that birds with poor foot health spent more time performing balancing movements while perching, and that makes sense. You can imagine how hard it might be to hold onto a round pole if your hands were swollen. And just like with footpad problems, LeBlanc also found that birds with keelbone fractures had to make more corrections to stay on the perch. The keel bone is the point of attachment for the big bird's wing flapping muscles, and fractures to this bone are considered one of the most important welfare problems affecting commercial laying hens. Many of these fractures happen when a bird has a high impact collision with something in her environment, like a metal perch. Hirkens and colleagues surveyed 47 flocks of birds aged 60 weeks housed in aviaries in Belgium. They found that footpad conditions like hyperkeratosis, dermatitis, and bumblefoot were affecting a substantial number of birds, and that for their keels, over half the birds had deviations and fractures. Various studies have shown that keel fractures can range in prevalence from 35% all the way up to 97%, which can be quite alarming. With an average of 28.6 million laying hens in Canada, that means that there could be up to 27.7 million hens with keelbone fractures right now. Typically, laying hens in Canada are housed until 70 weeks of age, but now producers are trying to keep their birds for an extended lay, so between 90 and 100 weeks of age, like they do in Europe. This can mean that we're subjecting these birds to painful conditions for a longer period without proper support. There are multiple studies that have found the benefits of ramps on reducing the prevalence of keel and footpad disorders. However, to my knowledge, very few have looked at the effect of those disorders on the use of ramps. And with this information in mind, it led us to the following research question. Do foot health problems and keel bone damage affect an older laying hen's method of ascending to and descending from elevated structures? For our objectives, we wanted to determine the method of ascending to and descending from the structures, determine whether a hen's health condition affected her method of ascent and descent, and to identify any strain differences. So this project was part of an overall preference test looking at how the bird's health condition affected her preference for a roosting structure. So we used 2 strains of commercially available laying hens, Bovins Brown and DeKalb White, both 70 weeks of age, and 1 non-commercial strain of White Leghorn, 54 weeks of age. For the overall preference test, we made comparisons of 3 different roosting structures that you can see here in the photos, with ramps positioned at 45 degrees. But for this presentation, we won't focus on the preference for structure, but rather the method the birds used to get there. We had 4 pens per strain with 8 birds in each, 2 from each health condition. And to select the birds for this trial, we performed keel palpations and footpad scoring on a larger population of birds and found birds that were healthy, birds with footpad problems, birds with keel bone damage, and birds that had both. We then took radiographs of this smaller group to confirm their health condition. So here's an example of what we considered a healthy bird. As you can see, her feet appear normal with no lesions or swelling, and her keel bone has no fractures. This is what we would consider a bird of the keel group. So she has good feet, but her keel has a fracture, which you can see circled in red. For the footpad group, they had a good keel, but their feet had visible swelling and lesions, like the photo on the left showing a condition called bumblefoot, or excessive skin thickening, like the photo on the right showing hyperkeratosis. And finally, the both group had both poor foot and keel conditions. We video recorded the birds continuously for 48 hours each week over 6 weeks. We performed behavioral observations to identify how each bird was ascending to and descending from the roosting structures and categorized them as aerial when they jumped or flew, and ramp when they used the ramp partially or entirely. We had 12 days of video footage, 12 pens, and 8 birds per pen, giving us a total of 1,152 possible events of ascent and descent by the birds. From this, we created some frequency distributions with the number of events. So here you can see the frequency distribution for the number of events based on the bird's strain and the method they used. But we also did this for each health condition and structure. So from these, we calculated the percentage of events, and due to birds sleeping on the ground, some missing observations from technical difficulties, and 2 birds being removed from the trial during period 3, of the possible 1,152 events we could have observed, we saw 747 at dawn and 771 at dusk. We ran a generalized linear mixed model with a log normal distribution using SAS Studio clock limits on the percentage of events. My fixed effects were strain, condition, structure, and method, along with their interactions, and my random effect was period. Because the observations for individual birds were imbalanced, we couldn't account for repeated measures in the model, so all events were treated as individual observations. And the results presented are based on the raw data rather than the back-transformed means. So for my first objective of this study, it was to determine what method the birds chose to ascend to and descend from their roost. So we can see here on the left that when the birds are ascending to their roost at dusk, they're going to use the ramp more than half the time. Whereas at dawn, when they're descending from their roost, they're using aerial locomotion. My second objective was to see if the bird's health condition impacted her choice of method. So these graphs show the percentage of events we saw per health condition. And on the left, we see the birds using aerial and the ramp pretty evenly, whereas on the right, aerial was used the most, no matter the health condition. And finally, my third objective was to determine if there were any strain differences in the method the birds chose. We found that when ascending to the roosting location at dusk on the left, the brown and white birds tended to use the ramp more. Something we found interesting was that for the white leghorns, they tended to use the aerial locomotion to ascend to the roost, which we weren't expecting. So after seeing this result, we realized that it might have been related to the differences between the white leghorns and the DeKalb white and Bovins brown. So their age being different, as well as how they were raised. The Bovins brown and DeKalb white birds were raised in aviaries that had ramps, and the white leghorns had never had ramps before. And we now have a growing body of evidence showing that birds tend to take longer to use structures in their adult environment if they've never had them in their rearing environment. So this was a limitation of our experimental design, unfortunately, because we needed older laying hens with our various health conditions, and we had a little bit of a time constraint. So in conclusion, the birds chose aerial methods of locomotion when descending. Ramps were used far more when ascending to their roosting location. Health condition and structure didn't influence their ascent or descent. And birds with previous experience with ramps used them far more than birds that had never seen them. The key takeaway from this trial is that ramps are an important element in non-cage systems that should be a requirement. To help illustrate the importance, I'd like to show you a little video. Here in the bottom left corner, you'll see bird number 5. She was identified as having both foot and keel problems. And you can see she tries to get up on the perch, but she isn't successful. However, she isn't discouraged. She knows there's another way and decides to use the ramp to get onto the perch for the night. At the beginning of this presentation, I told you that birds could be living in environments that may not match their individual needs. I think it's clear that with the simple addition of ramps, birds, no matter the strain, health condition, or individual preference, can all make their ramp to roost journey. Thank you.